Good morning, good afternoon, and good evening. In video number 47, I repaired an LED bulb, and I mentioned in that video that I had made a change to the board in order to reduce the power by half. So in this video I have a working bulb here, and I will show the steps that I took to reduce the power in half, because I want to do the same thing to this bulb. So let's dive right in. This bulb is 5.5 watts, 43 milliamps, warm white. Let me quickly show you that the bulb is actually works. There we go. Alright, so now I will carefully remove the plastic cover here. As you can see, there's like silicone in here that holds it in place. So I'm going to remove the silicone next as best as I can. Okay, I finally managed to remove the LED part of the bulb, which it has these two metal tabs that catch onto these two metal bits, and that's what gives the power to the LEDs. Alright, now I'm going to remove the bottom part. And there's a cable here, there's a wire. You see the wire right there. And this pin pushes it into place and holds it steady. So now this board can be removed. We'll have to use a bit of force because, like I said, the other wire is secured to this screwed on part. So I'm using extra power. Bring it out. Hopefully the wire comes out. There we go. Let's take a quick look at the board under the microscope. So this is one end of the right here. This is one end of the bulb, and that goes through the screw at the bottom. This part here, the screw at the bottom, the one that's secured by the push pin. And then the other one is just the other line here. This one is secured by this crimped on screw part. Now the change we need to make is on the other side. And I'll have to figure out which resistor, because this one is a bit different from the other bulb that I worked on. So I'll need to figure out which of these resistor is the current sense resistor. Shouldn't be too hard to figure out. Okay, so I looked up the spec sheet of the main IC here, the driver IC, which is, as you can see there, it's the 9918C. So I looked up the spec sheet, and basically the current sense pin is this one right here. So I suspect that these two resistors, R2 and R3, are the two resistors in parallel that basically go to the current sense pin here. So I suspect that these two resistors are in parallel. We're going to check for that. And it looks like they are 8.2 ohms each. And so if they are in parallel, they will be a total of 4.1. And so once we confirm all that, I can remove one of these two, and this should double the resistance to 8.2, because we're going to remove one of them, and will reduce the power by half and thus extend the life of this LED. Let's do some checking first. Okay, I secured the board a bit better and changed the orientation so we can do the measurements a bit easier. So this is pin number 3 right here. And it should go to one end of this resistor, not here. There we go. And I'm betting it's this one also, this end. Yeah. So these two ends are connected together. A bit more light. Okay. These two ends here and here should be connected. And then these two ends, the other two ends, should be connected as well. And they are. And let's measure the total resistance. So I'm going to put it in resistance mode. Okay. Let's measure the total resistance. It should be 4.1. And I'm getting 4.2, which is close enough. And that should double once I remove one of these two resistors. Now, the next thing I'm going to do is I'm going to attach this board back to the LED, back to this. I'm going to attach it back to this, and I'm going to use the multimeter in amp mode to measure how much amp is being drawn currently, because that current draw should be cut in half after we remove that resistor and complete the modification to the board. Let me get things set up and I'll be back. Alright, so we're back. I've set up everything. I'm unplugged at the moment. But basically I've put my multimeter in series so that we can measure the amps. And when I touch this end of the probe to the terminal here, the light will come on and it will show us what the amp draw is. And we're going to make a note of that amp draw, because after I remove the one of the resistors from the board, this amp draw should be cut in half. Alright, let's see what amp draw we get now. I'm going to put this on amps, DC. And so, okay. Here we go. And we're drawing 73 milliamps. Again, I'm unplugged. Okay, so 73 milliamps. Let me double check the voltage on the main capacitor. Make sure it's safe to handle it. Alright, the main capacitor is here. And we have less than 1 volt. So we're safe to handle this. Alright, so now I'm going to make the modification by removing one of the two resistors we mentioned before. I think I will use, should I use hot air or just my soldering iron? Let me think about it and then I'll come back. Alright, I decided I'm going to use hot air and I'm going to remove this resistor right here. Let's do it. 400 degrees and 50% airflow. Aten 862D. There we go. Let's do some measurements now to see what we have now. Switch the multimeter back to normal mode. I'm in resistance mode. Before we measured 4.2 ohms. Now it should be around 8.2. 8.4 ohms. I don't know if you can see that. Let me go to the other view. Okay, so there you go. 8.5, 8.4, 8.5 ohms. So in essence that has doubled the resistance, which should cut the current by half. Okay, so the next thing I'm going to do is I'm keeping this the same, not making any changes to this one here. But this one, I want to put a different wire and I want to make it longer so that if I ever need to do maintenance on this bulb, it will be easy to remove without having to use any force. So let me do that now. So I'm going to start by moving the existing. And I'm going to do the quick. Alright, I found the cable that I will use. I'm going to strip it and tin it. I'm going to first put it through the base and solder it. Here we go. So I basically put it through. You can see the cable right there, the wire. And I'm just going to solder it to the shell at the top as much as I can to the top. And plus. I'm going to quickly check continuity. So it should connect to the shell here. And let's touch the other end. Yeah, we're good. Okay, now I'm gonna solder it onto the actual board. The flux. Yeah, I think that's all good. Let me trim it slightly. So let's check the amps now. Let me set things up. Alright, so I've reconnected everything. And if you recall, previously we had 73 milliamps. I'm going to plug in now. Put this on amps DC. Let's see what we get now. So we went from 73 milliamps to 36.7, as you can see. So we've cut the power pretty much in half. So now I'm going to put this back through, put this pin here, let it go, the wire go through the hole at the bottom. There we go. So now, as you can see, it's there. And I will just bend it and then seal it with this pin. And I put a bit of a red marker there, as you can see, so that I can identify the positive side. And I have a red marker here for the positive end. So let me match those. Push them back in. And we can go find this. There we go. That clicked into place very nicely. I don't know if you'll be able to see the pins. Yeah, you can see them right there. And then I should probably add a bit of silicone, but for now, no, this is holding fairly tightly, so no need for silicone. Let's proceed to the test. Let me get the light bulb stand. Alright, and we're back. Final test. I'm going to plug it in now. There we go. And this is half power now, so it was rated for 5.5 watts. So you're probably seeing here maybe 2.5 watts. Well, I hope you enjoyed this video and see you on the next one. Bye bye.